Good day, my friends. As we were told in our previous video about valencies, oxidation number, and symbols of some elements, we equally told you about radicals, their valencies, and oxidation number. For example, we told you, give you a table like this. We told you can have some radicals like triazo, 5-ion. Can also have hydroxyl ion or hydroxide ion, ammonium, etc. etc. Now to do the symbol for this NO. This is the formula. NO3 minus, formula for this OH minus, formula for this NH4 plus, and others which you already have. So this one, position number is -1, position number is -1, position number of this is +1, valency is 1, 1, 1. The same thing applies to the rest. So today we are going to write some chemical formulas using all these valencies and radicals. Let's assume we are told to write the chemical formula of potassium chloride. Write the chemical formula of potassium chloride. We just touch some examples. We say solution potassium chloride. We do about 2 examples or 3. Potassium, the symbol is K. Chloride, the symbol is Cl. And we know that the oxidation number, as the oxidation number method, can also use valency. The number of potassium, remember K is 19, 2881. Can give out 1 electron to form K plus, meaning +1. So we have plus here, and this is minus. Then you have exchange of valencies. You have changed your valency or oxidation number. Instead of oxidation number, this charge will always cancel this charge, making 1 here and 1 here. So it now become K1 Cl1. But there is no need of writing K1, so you just write KCl. This is the formula of potassium chloride. No need to write 1. So let's say we are done with that. I'll give you about 3 examples. Let's say we are also told again to write the chemical formula of ammonium tetraoxosulfate 6. It's a simple thing. You say solution. Always present your work in a way to be appreciated. You write the name again, ammonium tetraoxosulfate 6. Both of them have to do with radicals. Ammonium is NH4 plus, tetraoxosulfate 6 is SO4 2 minus. You see it. Now the charge will cancel itself out. That is the oxidation number. The charge will cancel itself out. The charge the radicals carry. So if you exchange their valency, these 2 will come here and this 1 will come here, making NH4 2 is standing for all SO41. No need to write it. So this is the chemical formula of that compound. Now I think this one will be okay. Here, it has to do with chemical formula. This one will help you, guide you on remembering the previous ones you have been taught. Now let's go to let's do one more. Aluminium aluminium tetraoxo oxosulfate 6. Aluminium is Al as a symbol. Tetraoxo 6 is SO4 2 minus. You see it. But the aluminium has atomic number of 13 and the breakdown is electronic configuration 283, meaning it can give out 3 electrons to form Al3 plus. Therefore, you have 3 plus here. Okay? Then you count the charge will cancel out and you exchange their valency. You can write it here, valency exchange. 2 will come here, 3 will come this way. Therefore, when you want to write the chemical formula, it becomes Al2. Because this one is a group, you put bracket SO4 I think this one will cause you to remember the other ones you have been taught. Now, let's go to balancing of chemical equation. We'll also give you a very few ones. First of all, chemical equation. Chemical equation by definition is the process of representing chemical change using symbols and valencies, symbols and formulas. That is what we call chemical equation, representing chemical change using symbols and formula. For example, remember when you are writing chemical equation, you have two sides. You have the side of the reactant, which is also always written on the left-hand side, and you have the side of the product. For example, if you are giving A plus B to give you C plus D, this is the side, this is the left-hand side, which is usually reactant. This is right-hand side, which is the product. Let's give it real elements. Let's say I have let's say CaCO3. The composition of potassium trisulfide. Okay, let's just use CaCO3 plus HCl to give you CaCl2 plus H2O plus CO2. You have to put 2 here. So these ones are the reactants. They are the ones combining together, and this one is called the product. They are the things that are formed. Now, the product and the reactants, they are usually separated with this arrow. The arrow is always pointing towards the side of the product. Sometimes you can have a reaction that can proceed both ways when the conditions are changed. Such reactions are called reversible reactions. Reversible reactions. Reversible reactions. And for example, even this decomposition I was telling you about, CaCO3, you have something like this. When you heat it, it decomposes to CaO plus CO2 inside a closed vessel. So you have this one. If you heat this, it will decompose to this. But if you don't allow it to escape, both of them will react together to form this. So this one is the forward reaction, half of the arrow. The remaining one is the reverse reaction. We also have the common one I gave before, N2 plus 3H2 to give you 2NH3. Both of them combine to form product. If this product dissociates again, it will form back reactant. Such reactions are called reversible reactions. Let's give an example of how to balance simple chemical equations. This one will now help you to go and study more so that you can remember the rest. Let's say, for example, you want to balance equation. You have balance the equations below. Let's say, for example, you have H2 plus O2. Remember, this one is revision, H2O. They just said H2 plus O2 to give you H2O. What you have to do first is use method of atom count. You recopy it again to have this. You now say H2 plus O2 to give you H2O. That's the solution we are trying to address. Now, hydrogen here has 2, while oxygen has 2. But in this place, there must be a demarcation line because we are using method of atom count. Atom count. That is simply method of counting the atoms. Hydrogen here is 2 because it's 2 here. Oxygen here is 1. What do we do? Both these 2 hydrogens are the same, but these are not the same. So we can just say this times 1, which is 2. This times 2, which is 2. That's use this one to multiply this. Use this one to multiply, making this. Just pick one, even if it's a complex one. Pick one, and will help you out. So since we have multiplied this one by 1, this one remains there. We have now multiplied this one, oxygen, by 2. You cannot add to the base, you must put it at the back. So you have 2, this one, adding 2 here because of hydrogen, we offset this. Because of oxygen, we offset this hydrogen, making 2 times 2 now will give you 4. That is why most often you balance with pencil. When you now come out with the final answer, you print it out with biro, or you write the final answer with biro. Especially when it's not practical. Practical is when it is forbidden to use pencil in external exams. So this one is 4 hydrogen. If you look at it now, this one become 4. Therefore, this one must be multiplied again by 2 to become 4. You put 2 here. 2 times 2 is 4. 2 times 2 is 4. This is O2, which is 2. 2 stands for this 2, so it's balanced. So that is how you balance chemical equation. Let's do another example. Please don't forget, there are several other methods that can be used. The one that is most suitable for you is the one you are advised to use. Let's say number 2, you have KClO3. This one gives you KCl plus O2. This is the configuration of oxygen that determines the, you must heat it. This means heating in chemistry. That determines the composition of potassium trichloride. Now you look at it, here you have use atom count. Here you have potassium, chlorine, and you have oxygen. Demarcation line, potassium, chlorine, and you have oxygen. Let the C always be capital. You have oxygen. So let's count. Potassium is 1, chlorine is 1, oxygen is 3. Here, potassium is 1, chlorine is 1, oxygen is 2. You see it. So you just pick one that is different. You look at it, potassium is 1 here, 1 here, oxygen is 2 here, oxygen is 3 here. So what do? Let's assume we multiply this one by this 2 times 2 equals 6. Multiply this one by 3 times 3 equals 6. So both of them are not the same. It means therefore we find a way of making this oxygen 6. And the only way we cannot add to the base, we put 2 here. 2 times 3 becomes 6. For this oxygen, you put 3 here too. 3 times 2 equals 6. But by putting 2 here, it now offsets the rest. Therefore, potassium here will be 1 times 2, which is 2. You see it? And chlorine here is 1 times 2, which is 2. To know how to balance it, you have to put 2 here. 1 times 2 equals 2. 1 times 2 equals 2. So everything is equal. So it's balanced. Then let's do the one that involves combination and combination reaction. Any one we are comfortable with. And theory, remember, you can use other methods. Several tests will give you different methods of balancing chemical equation. Let's use the neutralization reaction. NaOH plus H2SO4 to give you Na2SO4 plus H2O. You see it? NaOH plus H2SO4. Na2SO4 plus H2O. If you look at it here, you have, using atom count, put a demarcation line. You have sodium here, oxygen, hydrogen. Then you have hydrogen, yes. You have SO. Since the SO4 did not decompose, it remain the same here. You can separate it or you can use it as a radical. Here, I'm going to use my own as a radical. But you can also separate it to give you the same answer. So here you have NaOH and SO4. Like I said, you can break it down to S. Oxygen is already here already. Whichever way. This one is quicker. You have sodium here is 1. Oxygen here is 1. H is 1 plus 2. This is 2, making 3. SO4 is 1. Here, oxygen is 2. SO4 is 1. Because it's a group. We are taking it as a group. Then oxygen is here 1. Hydrogen is 2. Let's see the one that is different in it. Sodium. Oxygen is the same. Hydrogen is 3. You can use any one, but I prefer we use the simple one. We just use the one that is easier. Then 1 times 2 equals 2, because I didn't want to multiply this. Then 2 times 1 equals 2. So 1 times 2 is 2. So you have to put 2, so 2 here. Then 2 times 1 is 2, because it's one that was initially here. So this one still remains 2. So when you have here, you see oxygen now change. Times 2 equals 2. For hydrogen, it will now be 2 here, because you have 2 plus this 2 equals 4. 2 plus no longer 3, there's 4. SO4 2 still remains there. SO4 remains there. Then for this sodium is 2 already, so SO4 remains there. Then hydrogen is 2 here. What do we have as hydrogen? 4. Therefore we must add 2 to this. 2 times 2 here will be 4. The oxygen will now be 2 here. 1 times 2 equals 2. So let's see whether it's balanced. 2, 2, 2, 2, 4 hydrogen, 4 hydrogen, SO4, SO4. So this is how you balance chemical equation. Since you have been, I'll just do a brief revision on how to balance chemical equation. I hope you sit down properly and go through it. Thank you.